becomes 2 pi times the radius, which was 4, equals 8 pi. Circle C, circumference equals 2 pi r, 2 pi times 3 equals 6 pi. The last one, circle D, 2 pi times the radius, which was 1, equals 2 pi. So determine the perimeter scale factors by completing the following. The perimeter of scale factor of B from A. So we get B circumference to A circumference is 8 pi over 4 pi, which if you divide you get 2 over 1, which you get 2. The perimeter scale factor of C from A, so we need to take the perimeter of C, which is 6 pi. 6 pi over A, which was 4 pi, equals 3 over 2, which equals 1.5. And the last one, we'll get 2 pi over 4 pi, which equals 1 over 2, which equals 0.5. So if you notice, that's the same scale factors as when we did just the radii. So complete the following to investigate the relationship between linear scale factor and perimeter scale factor. The first one has been done. So the original dimensions of the rectangle, the original perimeter, the linear scale factor, the new dimensions of the rectangle, and the new perimeter. So you can read that was 3 by 5, the original perimeter was 16, the linear scale factor was 2 to 1, and the perimeter scale factor is 2. So I'm going to go through this fairly quickly. So original dimensions of rectangle Q. So we've got 2 times 6, so the original perimeter, well, you've got 2 plus 2 plus 6 plus 6, so the entire perimeter is going to be 16 centimeters. And these, you don't see these rectangles in your book, you just have to envision them, or you can make a small sketch. So the linear scale factor of the length times the width would be 3 to 1, so that's 6 and 2 just reduced, or 3. So the new dimensions of the rectangle is going to be 6 times 18. And the new perimeter would be 48, because we're multiplying each thing by scale factor of 3. So the width goes by 3, and the length goes by 3. So 2 times 3 is 6, and 6 times 3 is 18. So the new perimeter is 48 over the original perimeter of 16, and you'll see we get our scale factor of 3. Okay, so we've got a new rectangle here. So it's 9 by 6. That's actually looks more the other way. Oops. So again, we're just envisioning a little rectangle that's 9 by 6. So the original perimeter will be 6 plus 6 plus 9 plus 9, which if you add up is 30. Our scale factor is 1 to 3, or 1/3, so we're actually going smaller. So each thing needs to be divided by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. So this was our original rectangle, and now we've applied a scale factor of 1/3 to get a rectangle that's smaller. So the new dimensions of the rectangle is 3 by 2, which has a new perimeter of 10. So if we take the new perimeter over the old perimeter, we get our scale factor of 1/3. Okay, last one, we've got a rectangle that's 3 by 12. So the width would be 3 and the length would be 12. So 3 plus 3 plus 12 plus 12 would be original perimeter of 30 centimeters. Our scale factor is 2/3, so each thing needs to be divided by 2/3. So our new dimensions are going to be 2 by 8. If we divide 3 by 2/3, we get 2. And if we divide 12 by 2/3, we get 8. So the new perimeter is 20 centimeters, and the perimeter scale factor is 20 over 30, which it gives us a scale factor of 2/3. Now if this part's confusing, just come see me, and I'll explain it a little further. So the perimeter scale factor should equal the linear scale factor. If you don't get that, you've done something incorrectly. Alright, complete the table using the linear scale factors in A. So the linear scale factor of rectangle P, which remember we just had to envision or make our own sketch, the linear scale factor was 2, which means it is an enlargement. It's getting bigger. Linear scale factor rectangle Q was 3, which means it's an enlargement. It got bigger. Linear scale factor of R was 1/3, which means it's a reduction. It's getting smaller. Hard to write. And the last one was 2/3, which again is a reduction because it's getting smaller. Class example 1, determine the scale factor that will transform diagram P to diagram Q. Give your answer as a ratio, a rational number, and a percent. So if we look at this, look at the original, the photocopy got bent a little bit, but you'll have to trust me that that's 3, and this is 4. Okay, so we're going from P to Q. So our original scale factor, the ratio will be 3 to 4, and a rational number will be 3/4, which gives us 0.75, or a percent, which is 75%. So if you look at it, the new one was 3, the new width was 3, the old one was 4, so we do 3 to 4, which is 3 to 4. And then if we put that as a rational number, we get 75, which translated to a percent gives you 75%. So this triangle is 75% as big as triangle P. Sarah increased the length and width of a rectangular 8x10 photograph by a factor of 5 to 2. Is this an enlargement or reduction? Well, if we take 5/2, we reduce that to 2.5, it's bigger than 1, so we know it's an enlargement. Calculate the new dimensions of the picture. So if every dimension gets increased by a scale factor of 5/2, let's do the length. So the length was 8. It's an 8x10 photograph. We're going to multiply it by 5/2, scale factor, and it equals 20 centimeters, or 20 inches rather. And the width was 10 inches. We're going to multiply it by a scale factor of 5/2, and we're going to get 25 inches. So the new picture is 20 inches by 25 inches. So show that the ratio, the new perimeter, 5/2, that it equals 5/2. The new perimeter over the original perimeter equals 5/2. And the new perimeter, is going to be 20 by 25, so we got to add all these up, and it equals 90. And the old was an 8x10, so 8x10, if we add up all these, you'll get 36. So if we do 90/36, we'll get the same scale factor. These are the same, so we're all good.